Okay, we're going to go ahead and discuss things starting in Chapter 2, Section 6. We're going to be discussing, as we see here, rational functions. Okay, so rational functions are functions that have basically look like a fraction. They have a numerator and a denominator, and the numerator is built up of a polynomial function. So we're going to refer to this as the book says, n of x. Okay, now n of x is just a polynomial. Remember, the polynomial is just like something like x cubed plus x squared with coefficients in front. And that's all divided by a d of x. Now, we use, in this case, the notation n of x and d of x to refer to the polynomial of our numerator and our polynomial of our denominator. The first thing we want to find is our domain. Okay, our domain. Now our domain of a rational function is very easy to find if we follow this step. 1. Take d of x, okay, and think of it that d of x cannot equal 0. So we've used all the ways we can to find zeros of a polynomial. We usually always use zero factored form. Okay, zero factored form, where we go ahead, if we have a quadratic, we can use the quadratic formula to find the zeros. But typically, we use our normal factoring techniques, or in some cases, the problem will just be given to us in zero factored form. So remember, all you have to do to find the domain is set the denominator not equal to 0, and you're good to go. Okay? So that's that step. So let's go ahead and see what, oh, sorry. Let's see what they have for an example here. They don't. So let's make one up. So let's make a rational function. We're going to call our rational function r of x. So let's write that down. And r of x is equal to, we could pick whatever we want. Okay, let's not worry about it so much. Let's just say x plus 3 upstairs. And let's say x minus 2. And then downstairs, we'll put it in zero factored form. We'll have x plus 1, and then we'll have x minus 3. So this rational function now has a domain, okay, colon, of all real numbers except for when the denominator is equal to 0. So we see the denominator, if we just examine these two zero factors, are going to be 0 when x is either negative 1 or 3. So now we just write the domain of our function is all real numbers all the way up to negative 1, but not inclusive. And then we have from negative 1 to 3, non-inclusive, because we have to take 3 out. And finally, from 3 all the way to infinity. Okay? So just concentrate. Remember, the rule is the domain is where the denominator is not equal to 0. Okay? So let's write that rule. Domain is where denominator, and I'll just put denom for denominator, can't equal 0. If you use that procedure, you'll be okay. Now, if we had a quadratic, we could just use the quadratic formula. We could just say, for example, if this was distributed out, we would have the a, b, and c of the quadratic formula. Okay, so let's move on next. So now the biggest thing is we're going to talk about vertical asymptotes, and horizontal asymptotes. Now, horizontal asymptotes. Now, I am going to refer to these as VAs, and I'm going to refer to these as HAs. Okay, so I'm just going to say that shorthand, VAs and HAs. Now there are some rules that we use for finding VAs and HAs. Let's talk about, first of all, VAs. Okay, now VAs will be found, VAs found in the denominator. Okay, when you have it easily in zero factored form. Okay, all we're saying is, let's go back upstairs here and look at R of x. A VA is found in the denominator when it's in zero factored form, and our function is reduced. Okay? Now, that's important because if we have another function that is not reduced, then the appearance of a zero in the denominator would be what we call whole. So let's go ahead and realize that if we had the fraction 6/8 and we said let's reduce that, we would typically write it then as 3/4. So if I had a function, let's just put an equal sign, if I had x plus 2 times x minus 2, and then under here we had x minus 2 times x plus 4. X plus 4. Now, if we go ahead and see that we have a factor that's common, we could rewrite this function as x plus 2 over x plus 4, as long as x doesn't equal 2. So this function would give all the appearances that this function would, except for the fact that x minus 2 is not in our domain because we're using the rule here. Whatever we start with, we have to go ahead and accommodate the fact that x could never be 2. So while this function here is going to look almost identical to this one, there's going to be one thing missing. And what's missing is the point when x is 2. And that'll be a whole. Now if we plugged in x is 2 here, we would get 2 plus 2, which is 4. And we would get 2 plus 6, which is 2 plus 4, which is 6, and that would be 2/3. And it would appear that unless we say we can't let x be 2, that the point 2/3 would be on my graph. And in fact, it's not, because my original function over here did not have 2 in it to begin with. So we would put the whole at that point. Okay? So let's go ahead and continue with this idea. Okay, we're going to get a new page now. We're going to try to remember this function. That's x plus 2 over x plus 4. You've got that in your notes, but we won't be able to see it when I add a new page. So x plus 2 plus x plus 4. Okay, so what we want to do now, let's see if I can get this right thing here. Blank page. Oops. Grid page. Okay, we've got, I think we had, let's see if I could figure it out. I'll go back here. Okay, I thought, oh, there we are. Okay, so we had x plus 2 over x plus 4. X plus 2 over x plus 4. And that's our function. I think we called it R of x. Okay, if I called it something else on a previous page, let's go take a quick look. Quick. Aha, it's R of x. It's R of x. And x can't equal 2. X is not going to be equal to 2. Okay, so now we look at VAs and HAs. Okay, and I wanted to talk about VAs first. So we have VA now. Once it's reduced, okay, remember, reduced is going to be when the denominator is equal to 0. So that means that we got a VA when x plus 4 equals 0, or we have the, not or, let's just not get rid of or. Let's not say or that, let's erase that or. We have a VA, okay, at x is equal to negative 4. Okay, so let's start our graph now for this simple one. We have our x and y axis, and we're going to say at x is equal to negative 4 line. Okay, we're going to come through here, and that's our VA. So we're going to label our graphs VA at x equals, in this case, negative 4. Now, the horizontal asymptote has a bunch of rules, and you really need to go ahead and look at this chart and know the rules. But we're talking about for an HA, we're looking at end behavior, not anything other than end, not middle, but end. So what we're going to do is we're going to say, okay, what would our function be if we plugged in negative infinity? Now we don't have a number for negative infinity, so negative infinity for most functions is approximately equal to negative 100, f of negative 100. Okay, so we could plug it in. So remember, to find HAs, first we plug in f of negative infinity, which we could use f of negative 100, and, okay, both. That's the left side. That's the left side. And the right side, or when x is big positive, we're going to look at f of positive infinity. And positive infinity is going to be approximated by f of 100. And that's how we find our HAs. We just go from looking at what we think it would be out here and what would be out here. So let's go ahead and do this one now. So r of negative 100, which is going to resemble negative infinity, is equal to negative 100 plus 2 over negative 100 plus 4. And that's going to be negative 98 over negative, what's that, 96. Now we notice we have a negative and a negative. It means our answer is going to be a positive. And what we're going to go is, because 98 is a little bit bigger than 96, we're going to say this is like 1, but we're going to put a plus here. And we're going to plus up here. It's a superscript here. And what that means is that's going to be a little bit bigger than 1. Not much. And as we go to infinity, it's going to be a little bigger. And that's what this notation here means. Okay, that it's a little bit bigger than 1. So small of a number bigger than 1 that you really can't tell the difference. So if I look at my asymptote now, it's saying that here's my asymptote, y equals 1, because that's what it's saying. But the curve's going to come and approach the top of it, and it's not going to go below it. Okay, so that's that. So now we look at what's r of 100. Okay, r of 100 would be 100 plus 3 and 100 plus 4. Okay, and that comes out to be 103 over 104. Now we notice that that number is always going to be a little bit less than 1. And we write a number a little bit less than 1 minus. And this means a number like 0.999. So we could say that's approximately the 0.99999. Now I could say 5 nines here, 4 nines here. I just want you to get the idea. It's a number just below 1. So if I look at my asymptote, let's go back up here, okay, and look at my right side is going to come and it's going to go over the top. Okay? It's going to, not over the top, excuse me. It's going to come right underneath it. This other one, I was confused. I was looking at this number which said 1 plus. This says 1 minus. So when it comes in approaching this asymptote way out here, it's going to come in from underneath y equals 1. Okay, so that's the idea of HAs. remember, you plug in your mind negative 100 for a left side and positive 100 for the right side. Okay? Now your VAs, we've already talked about, are here. Now we're going to go into the next page here, and we're going to plot this curve, and then we're going to give you a couple problems to do for the rest of the period, and then you can go ahead and we'll talk Monday at how you did, and you're going to do the problems that I gave you for homework. Okay, so let's go ahead and finish this graphing. Okay, I'm going to remember that's x plus 2 over x plus 4. Okay, let's make a new page. Now, let's see how we do this. Undo, text, clear, create grid page. Okay, so x plus 2. Okay, let's take a look at it really quick. X plus 2 over x plus 4. Okay, r of x is x plus 2 over x plus 4. Okay, we've already established that we have our graph and we have a VA at negative 4 and negative 4, and then we have a HA at 1. So way out here, we have an HA. We really don't know what's going on in the middle, so I always like to keep my HAs out of the middle. So then we have an HA here of y is equal to 1, and that's an HA. And remember, we have an HA at, and we have a VA at. So I always want to make sure we know what we're talking about. So we've already determined, let's go back to the last sheet, that the left side goes in the top and the right side underneath. So I'm expecting my graph to come here underneath and this graph coming here. Okay, so the next thing I could do here is plot some points, but I want to look at the behavior around negative 4. Now I want you to think about what a terminology is, okay? So let's talk about it. I'm going to write the number 0 plus. Now when I write the 0 plus, that means it's a number like 0.0001. Something so small that's near 0, like that. Now if I write the notation 0 minus, what I'm talking about is a number that's a negative number. And it might be something so close to 0. And I'm not concerned with how many zeros I have here. What I'm concerned is that it's such a small number, but it's negative. Okay, so here's the remember. 0 plus means a number just to the right of 0. 0 minus means a number just to the left of 0. So now that same notation, let's understand it. If I write 3 plus, what I'm talking about is a number is like 3.0001. And if I write 3 minus, it's a number just to the left side of 3. In this case, it might be 2.999. Okay, let's go through one more example. If I write 4 minus, okay, what would that be? Well, a negative number just to the left of 4 minus would be the opposite of 4.0001. But if I wrote it 4 plus negative, I'm sorry, this is a negative. I wanted a negative here. Okay, and if I wrote negative 4 plus, negative 4 minus would be just, think of the number line. Here is the number line. Here's the number negative 4. Okay, what would this number be right next to it if it was really zoomed in? It would be negative 4.0001. What's this number here? Negative 3.999 with a bunch of 9s. You could write 29s if you want, or whatever. The idea is that's what the number represents. Okay, so before we finish our asymptotic analysis here, I want to think about what does 1 over 0 plus, what is that? What kind of number is that? Okay, I'm not going to put an equal sign there. Eventually we will learn that we could put it what it equals, kind of, but not really, because you'll see what the answer is going to be. So what is this number? It's 1 over like say 0.0001. Okay, so what is that number? Well, that's 1 over, let's see, that's 1/10,000th, right? That's like 1 over 10, 1 over 10,000. And remember, we could turn that into 10,000. So the smaller the number I find, the bigger the answer. So the smaller the number here in the denominator means the bigger the answer I get in the end. So finally what we write is that this number, if we want to say what is 1 over 0 plus, and that would be positive infinity. Okay, so that's an important thing to memorize. When it's 1 over, when you write 1 over 0 plus, it's 1 over infinity. Now let's examine what 1 over 0 minus is. Okay, now we're going to look at it like this way. 1 over 0 minus would be like 1 over 0.0001. And what we could do is we could write this as the opposite of 1 over 0.0001. Now we just did this problem, right? We just did this problem, and what did we get? We have analyzed that, and we said, well, wait a second, 1 over 0.0001, or a number like that, is going to be positive infinity. Okay? So this part is going to be positive infinity. Now the question then is, well, what's the real answer? Well, wait a second, you have a negative. So you got to bring the negative along, and so then you write negative. So if you write 1 over 0 minus, that's what you're going with, then that is like us saying negative infinity. Okay? And remember, negative infinity is just the number that we show as where it goes. Okay, so that brings us now to talking about this function here. We know what it does here. It goes to the left, and that's what it does. Okay? What does it do around this asymptote? Okay, so let's bring the work. You've got more room down here. I'm going to bring the work up here. So I want to look at what's happening just to the left of -4. So I'm looking at what is f of -4 minus. Okay, now what kind of number is -4 minus? Well, let's plug it in. Now, when we think of -4 minus, if it's not near 4, or we're not doing something with it right around, sorry, -4, we could just plug and chug it. Okay, so we could put it in our numerator. The difference between -4 and -4 minus, in this case, is insignificant. So we could write -4 plus 2. Because the difference between -4 minus and -4 plus 2 isn't going to matter. That number is going to be -2. However, now when we write -4 minus, let's write it down here as -4.001 plus 4. And what do we get when we do that? Well, remember, I could put in a lot more zeros if I want. But now I'm going to write this number as -2 over, we notice that when we combine these two, we get a -0.001. Now I actually could add more zeros. Now let's break this number apart. So first of all, we see we have two negatives. So this is going to be a positive answer. And it's going to be 2 times 1 over, in this case, what was that number? That number is 0 plus. Okay, that's what that represents when we looked at this part just of 1 over 0.001. Here it is, right down here. This is the type of number we're talking about right there. What is that type of number? Well, 1 over something really close to 0 is infinity. So we're going to say, well, wait a second. This is 2 times infinity. So this is going to be like saying 2 times infinity. Well, infinity is infinity. Double infinity is still infinity. So that means that as we approach from this side, going up to -4, my curve is going to go up to and unbounded towards the top, infinity. Okay? So that's how we find this arrow. Okay, I know this is, we're taking our time here. We're at 24 minutes. I hope you're still with me. Let's continue. Let's do this one now. Okay. Let's evaluate f of negative 4 plus. Okay, now everything's pretty much the same. The top is still going to be negative 2. We haven't touched that. And now we're going to get negative 3.999 plus 4. And what is that? That's going to be negative 2 over, and this one is 0.001. Well, we already know what 1, okay, what 1 over that is. That's infinity. So negative 2 times infinity is going to be a negative infinity. Okay, a negative infinity means our graph, if we're coming in this side, is going to go down here. This is going down, and this is where this comes from. Okay, from this answer here. Okay, next key thing is we know we don't have any zeros other than one now at negative 2. Okay, so at negative 2, I have a 0. So that means my curve has to go through negative 2. Okay, so that would be negative 2, 0. And we want to label a 0. Okay, that's that. Now, if you follow your book, okay, let's see, let's page next. The book talks, let's go back to the book. The book talks about these different curves and the asymptotes and the horizontal asymptotes. I want to see if the book is going to talk about, they're going to talk about these rules here on page 183. You want to study those rules, and we'll end up with those rules. Let's finish this curve. Let's figure out what the y-intercept is. The y-intercept is going to be found by plugging in f of 0 or r of 0. I'm sorry, I used f up here, and I really meant to use r. Okay, so we could have crossed this off in our notes, and we could say what's r of 4, because we called this thing r of x. We could write what r is. So now let me cross this off, and let me say what r is of 0. Because if we plug in x is 0, that's going to give us our y-intercept. We notice it's going to be 0 plus 2, which is 2 over 4. So now here is my y-intercept, and that's going to be the point now 0, 1/2. Okay, so we're there. Now we see we do not have any more. 0, 1/2 is below 1. Okay, there's my 1. We do not have any more zeros to the right, and we've already established that my curve goes underneath. I think my curve is just going to go underneath the asymptote. Okay, so let's go ahead and recap. We analyzed the left behavior by plugging in negative 100 to my curve, and then I examined it when I saw these rules where I could go ahead. Let's see, where is that at? That was on a previous page. Then I plug in 100 for that one. Then I look at what's happening next to an asymptote, and I find out if I have any other intercepts, and I use that, and I help shape my curve. Okay, so let's go ahead and end on discussing this box here. Okay, this box here talks about the degree of the numerator and denominator. In Algebra 2, you talked a little bit about this. So you knew that if you expanded out and looked at your n or your m represents the highest degree of the numerator, your n represents the highest degree of the denominator. All you have to do is look at this. The graph has asymptotes are vertical at zeros of the denominator, and then the degrees of the numerator over the denominator determine these rules. If the degree of the numerator is less than the denominator, you have a horizontal asymptote at y equals 0. If the graphs have the same degree, you look at the leading coefficients here. If the graph of n is greater than m, you have no horizontal asymptote, and we'll talk about that later. Okay, so what I want you to do now is look at finding your horizontal asymptotes. Let's look at our book now, and let's go down to the problems, and let's figure out what we want to do for homework, okay? So here I'm going to go ahead and add in a homework page. Okay, there we have it. Okay, so for homework today, okay, I want you to do page 190, 190. I want you to do problems 1 to 4. I want you to concentrate on vocab. Do that. Okay, the next thing I want you to do is I want you to use your calculator, and I want you to do problems 5 to 8 and plug and chug and fill out that table and start to get the feel for it. Okay? And then what I want you to do is go ahead and do every problem. Okay? And I know I'm kind of just marching down here. I want to do 9 through, and I want you to do finally all the way to 20. Now you're going to put these in your calculator and match them up. But before you do it, let's just kind of, for example, number 11 and all these. I want you to hand graft. Okay, so for 9, especially 9 to 20, I want you to hand graph first. Okay, that's what you do. You hand graft. And I want you to use the techniques that I showed you in that video. You can go home and look at the video again, hand graft those, and then put that function in your calculator, set the window up, and then determine what you think matches up. So if you looked at 11 here, you should see that what we did here is very similar to the problem I did for the example. You should be able to hand graph 11 okay. Okay? Try those. Use the table of values if you need, and then do that for this weekend's homework. And on Monday, we'll review what you did. Okay. Have a good weekend.